Hello friends, I welcome you in lecture number 35 on graph theory. In this lecture we will discuss the correspondence between general trees and binary trees. We will discuss that how we can represent given tree in terms of binary tree, and we will assume the fact that if we have any general tree, then we can represent it as a unique binary tree. And we are familiar with the definition of binary tree. A binary tree is a tree in which every internal vertex has no more than two children, and we will require the definition of sibling also. In a rooted tree, siblings are those vertices which have same parent. And if we have this type of vertices, suppose I have vertex A, and suppose this B, C and D are children of vertex A, then this vertex B is called leftmost child of vertex A, and this vertex D is called rightmost child of this parent A. Similarly, this vertex C is sibling of B, and it is called right sibling of vertex B. Similarly, this C and D are also siblings, they are having same parent A, therefore D is right sibling of node C or vertex C. So with all these things in our mind clear, we can discuss this lecture that how we can represent given tree in terms of unique binary tree. So what we have to remember is that if we want to represent a general tree as a binary tree, then all the nodes or all the vertices of binary tree will be same as all the nodes of general tree, and root of given general tree will be the root of binary tree. The binary tree which we want to construct, its root we will take as root of given tree. Now if we want to find out, suppose we start with root, suppose R is the root. Now suppose we are interested in the left child of this root R of binary tree, then left child of root R or of any vertex in binary tree will be equal to leftmost child of that vertex in a general T. Left child of node in a binary tree will be equal to leftmost child of the same node in a general tree. And what will be the right child of node in a binary tree? So that is equal to right sibling of the same node in a general tree. So we will remember these remarks that all the nodes of binary tree will be the same as the nodes of the general tree, and root of binary tree is same as root of general tree. Left child of any vertex in binary tree is same as leftmost child of that vertex in general tree, and right child of vertex in binary tree is same as right sibling of the same vertex in general tree. So with these three remarks in our mind, we can represent this directed tree as a binary tree, and this question was asked in GTU Summer 2022 exam. So here we observe that root of this general tree is 1. We can write here that this is nothing but general tree or given directed tree, and here we are going to construct or represent this general tree as a binary tree. So root of binary tree which we are going to construct will be same as the root of this general tree. Now we use this formula that left child of a vertex in binary tree is leftmost child of the vertex in general tree. So first we are interested in the left child of 1 in a binary tree. So we will look for leftmost child of 1 in general tree. So there are 4 children of 1 in general tree, which are 2, 3, 4 and 5, and 2 is the leftmost child of this 1 in general tree. So therefore here we will consider 2 as left child of 1. So here I am writing 2. Now right child of 1 in a binary tree is nothing but right sibling of 1 in general tree. But here we can see that 1 is the root, and therefore it is not the child of any other vertex. Therefore 1 has no siblings here. Therefore there is no right child in binary tree for this vertex 1. Now we come for 2. So same pattern we will follow, that left child of a vertex in a binary tree is leftmost child of vertex in general tree, and right child of vertex in binary tree is right sibling of vertex in general tree. Here left child of 1 is leftmost child of 1 in general tree, which is 2, and right child of 1 is right sibling of 1 in general tree, but 1 has no siblings, so 1 has no right child here. Now for 2 also we have to follow the same pattern. So left child of 2 is leftmost child of 2 in general tree, which is 6. So we will consider here, suppose we consider this as 6. 6 is the leftmost child of 2 in general tree. Therefore 6 is the left child of 2 in binary tree. Now right child of 2 is nothing but right sibling of 2 in general tree. So here siblings of 2 are 3, 4 and 5, because they are the children of same vertex 1. Therefore the right sibling of 2 is 3. So here we will consider right child of 2 as 3, and let me mention 3 here, and there is an age from 2 to 3, and this pattern we have to follow for each and every vertex. Suppose we check for 6. So left child of 6 is equal to leftmost child of 6 in general tree, but here 6 has no child, therefore 6 has no left child in binary tree. And right child of 6 is right sibling of 6 in general tree, and sibling of 6 is 7. So we will join 6 with 7, because 7 is the right sibling of 6. Therefore 7 is the right child of 6 in binary tree. Now for 7, left child of 7 will be equal to leftmost child of 7 in general tree, but 7 has no child in general tree. Therefore 7 has no left child. Right child of 7 will be right sibling of 7 in general tree, but 7 has no right sibling. So here we stop. Now we check for 3. Left child of 3 is equal to leftmost child of 3 in general tree, and here 3 has only one child. So if vertex has only one child, we will consider it as leftmost child. So therefore we will join 3 with 8 here, 3 and let me write 8 here. 8 is the left child of 3 because 8 is the leftmost child of 3 in general tree. Now right child of 3 is nothing but right sibling of 3 in general tree. So right sibling of 3 is 4. So here we will join 3 with 4. So here I have 4. This vertex is 4. Vertices are denoted by red color. Now for 8, we can first check for 8. So left child of 8 is leftmost child of 8 in general tree, but 8 has no child. Right child of 8 equal to right sibling of 8 in general tree, but 8 has no siblings. So here we stop. 8 becomes leaf. It has no children. Now left child of 4 equal to leftmost child of 4 in general tree, but 4 has no child, therefore 4 has no left child in binary tree. And right child of 4 equal to right sibling of 4 in general tree, and right sibling of 4 is 5 in general tree, therefore we will join 4 with 5. So I can use this type of directions. So suppose I consider 5 here, and 4 has no leftmost child here, and 5 is the right sibling of 4 in general tree. Now what about left child of 5 in binary tree? So that is nothing but leftmost child of 5 in general tree, which is 9. So I have to join 5 with 9 in binary tree. So here I have 9. 9 is the child of 5 in binary tree because 9 is the leftmost child of 5 in general tree, and right child of 5 is nothing but right sibling of 5, but 5 has no right sibling, therefore 5 has no right child. Now left child of 9 is the leftmost child of 9 in general tree, but 9 has no child, so 9 has no left child in binary tree. And right child of 9 is nothing but right sibling of 9 in general tree, and that is 10. 10 is the right sibling of 9 in general tree. So here I can write 10 as a right child of 9, and now 10 also has no leftmost child, or 10 has no child in general tree, therefore 10 also has no child, left child in binary tree. And right child of 10 in binary tree is right sibling of 10 in general tree, which is 11. So now I have to join 10 with 11. So here I am writing 11. Now 11 has no no child in general tree, as well as 11 has no siblings in general tree, therefore we stop here, and we can see that we have all the vertices 1 2 3 4 5 6 7 8 9 10 and 11 in our binary tree. Therefore this is the binary tree for this graph or this general tree which is given to us, and we have represented this directed general tree as a binary tree, and it is very easy to represent this type of general tree as a binary tree, and all we have to remember is that root of binary tree is same as root of general tree. Left child of a vertex in binary tree is equal to leftmost child of the vertex in general tree, and right child of vertex in binary tree is right sibling of the vertex in general tree. So you can see, let me shrink my screen. So here we can see that on the right hand side we have binary tree, and here so this is the binary tree, required binary tree for which general tree is given. So this is very easy correspondence. You can represent your general tree as a binary tree simply by considering these two formulas, that left child of a vertex in a binary tree is leftmost child of a vertex in general tree, and right child of a vertex in binary tree is right sibling of a vertex in general tree. So this is all about this session, and I hope you like it. Thanks for watching.